All right, here's our second part of section 14.4 where we started talking about implicit differentiation. We did some basic examples to kind of start us off, but let's get a little more complicated into it. Look at example number 1 with me. It asks us to find dy over dx. I want to find the derivative of y with respect to x. In this problem though, we've got lots of different variables all kind of intermingled. We've got x's, we've got y's, and now we even have an equal to sign. And so what we want to do is we want to find the derivative of this whole entire equation with respect to x. Okay, so if you were to find the derivative of this with respect to x, you would have to find the derivative of this first term. And so what derivative rule do you think you would have to use to find the derivative of 3xy? Okay, be careful, that's a product rule. That's one of the common mistakes that I see students make is you want to find the derivative of each little piece and then just smush them together. But remember, we can't do that. So if I were you, I would think of the first term as the 3x and the second term as the y and find the derivative using product rule. Find the derivative of this second term and then find the derivative of 10. Make sure that you find the derivative of each piece separately, and if you're finding the derivative of y, make sure you add that dy dx. Try it and see what you get. Here's what I got. I did the first, 3x, times the derivative of the second, so the derivative of y is 1 with a dy dx, plus the second, that's y, times the derivative of the first, so the derivative of 3x is 3, dx, but those reduced. Now I found the derivative of 4y squared. I got 8y dy over dx because that was the derivative. I found the derivative of y with respect to x. And now be careful on this right side. The derivative of any constant should be 0. So make sure you don't keep it at 10. Make sure that you continue to find the derivative of each little piece. That's another common mistake that I see students making, so be careful. All right, now this problem is a little bit different than the ones we started with in the last video because there was no equal to sign. On these problems, I actually want you to tell me what dy over dx is equal to. That means I need you to get all the dy dx's to one side, everything else without a dy dx to the other side, and I want your equation to say dy over dx equals. Okay, so in this next step, what I did is I just simplified each term, making it look a little bit nicer. So I have a 3x dy dx plus 3y plus 8y dy over dx equals 0. And so I notice that I have dy dx's in this term and this term. And so I'm going to keep them together on this same side, but I'm going to move this 3y over to the other side by subtracting it. I now notice that both of the terms on the left side each had a dy dx in it. So I'm going to GCF out a dy dx. When I GCF out a dy over dx, that should leave me with a 3x. Let's do this. I don't want to confuse you. There we go. That should leave me with a 3x plus 8y equal to negative 3y. Now if I want to get dy dx by itself, can I take that 3x plus 8y that's next to it and just divide it off? And so that's kind of what I did in the next step. Okay, so that means dy over dx is equal to negative 3y over 3x plus 8y. What this really is still my derivative. So he's still the instantaneous rate of change. He's still my slope of my tangent line. He's still the slope at one point. You should be able to find me the slope at any point if I give you the point, right? If I ask you to find me the slope of this line at the point 1, 3, couldn't you plug in a 1 for x and a 3 for y and find me the slope, the derivative? And that's all that this is, okay? All right, let's try another one. So over here, I have an x squared plus y squared equals xy. Why don't you try pausing the video, do this one, and see how far you get. All right, I got 2x plus 2y dy dx, and on this right side, you have to make sure that you use product rule. That's the first times the derivative of the second plus the second times the derivative of the first. Did you get what I got? All right, let's make it look a little bit nicer. Let's take all the terms that have dy dx's to one side, and let's move all the things without a dy dx to the other side. So I'm going to move my dy dx's to the right side. I'm going to move anything without a dy dx to the left side. It technically doesn't matter which side you move it to. We should all still get the same answer in the end. That's just what I decided to do on this one. You try it. So now I have a 2x minus y equal to x dy dx minus 2y dy dx. On that right side then, both of those terms have a dy dx in them, so you should be able to GCF out that dy dx, leaving you with an x minus 2y, and then you can divide both sides by that x minus 2y. You end up getting then dy dx is equal to 2x minus y over x minus 2y. The derivative, the slope of the tangent line, the instantaneous rate of change. Okay? All right, I know those are kind of complicated. Try those, practice those, and we'll do a few more examples in the next video for you.